Last class we did discuss about data encapsulation and then public, protected, and then local access, all these things. After that, parameterized classes. Okay. So why this data encapsulation means? Suppose you are entering your password, right? I need to protect my password. Someone to see. Okay. Someone they are capturing my password, right? Suppose you are entering bank details. Okay, your account number and then your password. So with the password only they can access. So then we need to give the protection to that. So it will be encrypted. Okay, in that way the data encapsulation will work here and it is wrapping that data and methods in a one class. Okay, so that is the use of data encapsulation. In that we are executing, we are discussing in that local and then protected after that public access. Public access anyone can access. And then local means same within the class only it is accessing. That means outside the class also they are not providing the access. Okay. Now protected classes. Okay. What is the use of protected access qualifiers in your system verilog? Okay. Protected means it will be accessed in the class as well as child class. That means suppose any uh, suppose any documents are there. Okay, so managers are discussing there. Manager and CEO is discussing with their captain. Okay, so within the class only they can access, right? So other person can't see the details. That is the reason they are using these protected qualifiers. Okay, suppose I am not there. So will you open my laptop? Okay. So teacher is not there, student is able to open the laptop? No, right? So they are not opening. So same way, so the class members only accessing the details. And then remaining people don't have any access. That means remaining people means test bench. Okay. So parent class is having the access as well as child class. That means within the family members only they can access. Suppose another example you have any room in your home is there. Suppose I came to your house. Okay, I can access only the lobby or hall only. So am I have the access to enter in the kitchen and then bedroom, all these things? No, right? So as a guest, I don't have the access. Same way, protected. See, who can access that? Family members only. Okay. So those family members only access their all the rooms and all the properties, right? Same way, here also protected qualifiers are used to protect the uh, confidential information. Okay. So suppose my driver want to drive the details only. I don't want to display the details in my driver. Okay. So driver is the responsibility to write the details to duty. Okay. There is no responsibility to show the details at the output side, right? So that is the reason I want to use in my child class and then parent class. Then I will go with the protected qualifiers. Okay. So in this protected qualifier, what are the things we are protecting? Variables we can protect. Okay, methods we can protect. Okay, that means functions are tasks. Okay, all these are we can protect. Then you are having a doubt. So then how can I access the variables in my TV? Through methods you can access. Okay, so through method you can access. Suppose the protected keyword is there in front of your variable name. Okay, int some count you are taking, or int a of I you are taking, or int some data you are taking, int address you are taking. Before that int you are having some what it called, you are having protected key, so then it is not accessible by the module, right? So the module cannot be accessed here. Clear? Understood, right? So this is the basic syntax: protected variable, class name, and then protected int address. Okay, This int address class transaction, suppose you are taking another class, so class some sequence item or item extends transaction. Okay, so from my sequence item something. Okay, transaction you are taking. From this transaction you are considering my sequence item or class APB sequence item extends transaction. Okay, so in this class also you are utilizing this address. That is possible. Okay, because the classes are family members only. Okay, same class members, parent and child. Okay, so then we are using this protected variables in your child class also, and then protected functions. Functions we are using the method function void display. So dollar display. This display I am utilizing in my class, and then this method is also accessed by the child class. Okay, so the function or task both are same, right? But tasks are using delays, functions are not having any delays. That's it, and it's nothing other than difference from this. Okay, what is this class transaction protected in data? Some variable example, how you are accessing this variable in your test bench. So I'm considering int data, and then method is, so through constructor we can access the data. What is the use of constructor? Function new, and then name your arguments you are assigning. That argument is assigned to your class number. Okay. So based on the constructor, I can assign the value to my protected variable. Okay, because this method constructor is the providing values to your, that means creating the memory or creating the object. So while creating the object only you are assigning the values. Without manually assigning the values, this constructor is assigning the values to your numbers and the properties, right? So that in that way I can access this protected member in my TB. Okay, so this is TB. But you don't have the permission to access directly transaction dot data equal to 100. So 1000. In this way, you don't have the access to provide manually. Okay, directly you can't access these protected variables in your test bench. Actually, how we are accessing in this way, right? So class, submit, address you are taking in the class. After that, your class transaction module TB inside that transaction some TR, and then initial begin TR equal to new. After that, TR dot address equal to some value or assigning. In this way, normal class we are doing, right? But whenever this protected variable is there, we can't access directly. Okay, clear? So how we are accessing the data here? See, I'm using this method called, I'm using this method, right? So this data I'm displaying in my method, because child can access this protected data, right? Access a class child transaction extends transaction. That means child transaction I'm considering from my parent. Okay. So in that I'm writing some method. Method function void display or show, print, whatever method name you want to write, you can write. Okay, so here I'm writing that show, or I can write print, or I can write display, anything. Okay, so then this method we are calling in our TB. Okay, transaction dot show. Then that method is going to your parent class. Then you are getting the value from the parent class. It is displayed in your child class. Then child class can give you the value for your test. Yeah. So this is protected variable. Okay. Similarly, protected method also I can access that. I told you no. So outside access is not allowed. How you are assigning? See, previously I told you transaction dot data equal to some value I have assigned. data 100, okay, 1000. I have changed that, but this is illegal because it is getting that the access to protected members, that is data not allowed in your PB. Then we will get the compilation error. Okay, so that is the reason I am not accessing this variable directly. Whoever the variables are protected by the protected keyword. Okay. Same way, protected method. So method you are considering previously normal method you are considering. Now I am considering method is protected. Here instead of function you also you can write task. Okay, protected task also you can consider that. Same way, this protected method is accessed by the child class. What is your class name? Sorry, method name? Calculation CRC. CRC is calculated. That is your method name. That method name I can call in my child class. Class packet extends transact packet is the child class. This is your child class and this is your parent class. Okay, parent or base class. Now I am calling this child class in my method CRC calculation CRC. So this is the method name. Calculation CRC is the method name. Okay, that method name I can call that in calling in my child class. Now how you are writing the module here? Module TB. Same way. What is your parent class? Transaction. Okay, handle is TR. And what is your child class? Okay, so packet, right? Okay, packet PKT. So in this way I can access that and initial begin. Okay, so you can initial begin. You can give the handle transaction tr equal to new. After that, transaction dot build I can call that. Okay, so here we can assign that transaction tr equal to packet pkt class assignment. I can call that transaction dot uh, build. I can call means this return value. What is the return value? Calculation CRC. That calculation CRC is representing your method in your parent class. That method is displaying at the output side. Okay. Same previous example you have seen, right? So child transaction tr and then tr equal to value, then tr we are calling through show. So I can call the show, then inside the show, what is the method is there? So that method will be displayed in your module. Same way, but I have written another line, right? Because I have created the handle for my parent and then child also. I have created the object for my parent and then assigned to child. Or you can create the object for your child and you can assign to parent. Okay, object assignment I can do. Based on that same memory it will show that and then we are getting the members of protected class. Okay, protected methods. That means parent class methods. Local versus protected. Local within the class only, parent only. Even child also don't know. Okay, child also can't have any access to uh, whatever the variables we have. That variables can't access that child class. That is the local within the class only, like CUs. Okay, so CUs and managers only. So they are only accessing the methods. So employees and then team leaders don't have the access to that. Okay. So in this way, that means only I want to display some properties in my parent class only. That means object only. Okay, object there is no parent for that. So that is only accessing as a parent. Okay, component we need parent. Okay, in that parent only I can access that. And then child class also I'm not permitting that, right? So that is called as local. Okay, public anyway. So anyone can access child, parent, and then PB. All these things are accessible, right? Okay, fine. Local versus protected means local int count I am considering here. That count cannot be accessed by your child because local only parent class. Okay, we don't have the access to, we don't have permission to access the child class. Okay, and then protected keyword you know already, so this protected keyword will access by the child class. So here I am using the count, that count will be incremented in my child class, and then that will be displayed at my tb by using this method name. Okay, increment method name. Same thing, protected configuration. How we are assigning the value? Through constructor, I told you. So constructor, we are having a new method. That new method in your TB, we can give the value. Okay. So how we are giving the value? See, transaction child we are having, right? So in module, I am giving the handle like this. So uh, transaction class. So what is the class name? Driver, right? So driver module TB, and then method you are using driver drv. So then drv equal to new of. So value you can assign that. Already he is assigned that function new timeout equal to 100. If you are not assigning in that, instead you are writing some variable here, timeout is there, then time I can write here. Okay, so then how we are assigning this one? Timeout equal to time. Okay, then you are assigning this argument int time you have considered. Now I have assigned this value 100 inside my new method. So this new method directly calls this constructor. Inside the constructor we have some arguments. That argument you are assigning to your class member. In that way I can assign the value. Understood? Protected counter, same thing. I can display same method, but another example. So counter we are taking, that counter is used in your scoreboard. Okay, scoreboard comparing that counters, how many counts will be there. Then expected count and then actual count both are equal. Then your scoreboard will be passed. Protected method reuse. That means you are using same protected method we can use in our TB also. Okay, our child class also. How we are using that? Calculation, right? So then CRC equal to calculation CRC. How we are assigning that? Function void int CRC. Then CRC is equals to calculation CRC. Then here I am utilizing that, reusing, same way. So previously we are using the constructor method. Instead of constructor method, I am utilizing the normal method only. In that normal method, we are having some arguments. That arguments we are assigning to protected variables. Okay, protected methods. In that way, I can operate. So that means I can access that. I can reuse that. Okay, protected with inheritance chain. Okay, inheritance chain means child class always extended, that means inherited that parent class properties and methods, right? So then inheritance anyways it will exist there. Because extends keyword is there means that child class always inherited that methods of parent class is available in your child class. Okay, that is inheritance. Then inheritance also it is obeying that. And chain method I have explained, right? Chain method means so what is the chain method? Uh, we have different objects, right? So transaction dot address you are giving that, and then we are assigning some value, and then transaction dot data equal to you are giving some value. By using the chain method, how we are assigning that? Transaction dot address, some value you are assigning that, dot data, some value you are assigning. You have seen, right? Chain method. Okay. So previous classes. So this is the verification environment, how we are assigning the protected functions in your TB. Same example, but different classes, different values. I'm considering this one. and also virtual. Okay, in polymorphism, we are using that virtual method and object assignment, inheritance. These three are there means your polymorphism will be there and dynamic binding will be happening. Okay, during runtime, many handles we are considering. Based on that, I am assigning the values to my child classes. Right. So same thing, the virtual method we can override it. Right. Same thing, I am using my protected virtual method in that child class. What is the name of this method? Display, right? So then I'm using the display method in my child class. I can call it as, okay. So allowed because child can access the protected methods, right? This is the final example. What is the class based driver? You are using that in protected in timeout, and that timeout value are assigning to method like constructor method. Okay, constructor method we are assigning some value. After that, protected function also I am considering. That means all methods and then variables also protected, right? So those two examples I'm considering here only in single example. So then class member child class can access this timeout as well as method. Okay, so print timeout method as well as timeout value in your child class. Okay, so then timeout value you are assigning through the method and then print timeout we are calling. Then these methods, this method, what is the method name? Run. I can call this run in my TB. Then obviously you are getting the properties and methods in your TB. Yeah. So studying this summary, just give me 2 minutes. Sir. See this example. Huh? Same example, just I'm taking the base driver. This is my parent class and protected int timeout. Inside that, I'm assigning the value for my timeout property. Okay, function new timeout equal to 100 and end function. After that, protected function void print timeout dollar display. So we are using this timeout equal to percentile 0d and then timer because uh, I am using this method to display that. Okay. So print timeout is the method inside that timeout equal to percentile 0d because I have assigned the value, right? I am displaying in my parent class. After that, I am considering AXI driver is the child class extended from the base driver. Okay. And then function void run. Inside run, I am utilizing timeout equal to 200 and print timeout. Okay, because I'm changing the value here in my child class, I'm calling this print timeout. This print timeout will display this timeout value, whatever the timeout value you are assigning, we will get in your child class because protected methods are accessible by the child, right? And then module TV, AXI driver is the child class handle. Okay, here object is null. After that, creating the new method, we are creating the object for your child class. Then calling the method in your TB. Which method you are calling? Child class method. Run. Driver dot run. Then you will get the value. Okay. See, timeout value is overridden by the child class. That means inheritance is obeyed. Okay, child class can modify that, and then we are getting the child class methods. Okay, and properties. Next one, protected maybe. So constant classes. What is that constant class properties? What is that constant class properties? In our office, they are using employee ID, name, all these things. Name will be changing. So your name and my name and different names. Employee IDs are not changing. Okay. So then we are giving that constant parameters, constant properties in your class and utilizing some constant uh, numbers or constant properties. Okay. So that means you are assigning the value to your member directly. Suppose int address you are taking. Inside that address you are hard coding means int address equal to some 10 you are giving. That means global constant. Okay. So global constant means it's not changing. So we have two types of constants, global constant and then instance constant. So global constant means you are assigning the value directly in your class number only. Okay. Suppose constant int id equal to 1 or constant int data equal to 10 or constant int address equal to some AA for that address only, for that data only, and then whatever the value you assign globally, that value only appear at your TB. You can't change the value. That is constant global constant parameter or global constant data type or global constant number. Okay. So understood, right? So globally, you're that means born with golden spoon. So someone born with golden spoon, they are calling, right? So that means what? Born with golden spoon means they have some features. Okay, without hesitate to what is happening in my life and all these things. They don't care about that, right? Same thing here also. Protect global constants are there means in that while assigning the members only we are giving the values. Okay, we are providing the values. That values are not changing. Okay, so that means cannot be changed. And an instance constant means constant is there, but you can assign the value through constructor or method. Okay, because previously we saw right protected access. How we are giving the values to the protected access variables through methods only or through constructor only. Same way here also we can give the constructor and then we can assign the value. So here constant id created empty. So assign once in the constructor, never change afterwards. Okay, that means once you are assigning the value to the constructor, then it cannot be changed. If you want to change, you can create multiple objects. Clear? Because constructor method is there. But child class, we are parent class or child class, you are writing the constructor. That means after that, how we are changing the data in your constructor, I can create the multiple objects, right? Class transaction. For my transaction TR1, TR2, TR3, TR4. Four transactions, four handles I have created. For that four handles TR1 equal to new. In that 100 I have assigned. TR dot TR2 equal to new of 200. That means 200 you are assigning. All these values are displayed, right? So because I am calling that transaction dot print, transaction one dot print, transaction two dot print in this way, I am calling my method. then this value will be assigned to your constructor. That value will be displayed at the output side. Here, so this is the global constant we can't change. Once you are assigning the value, what you are assigning class transaction is my parent class and bit. So 32-bit data. So this is not a constant, normal public variable, right? Public number. This will be appeared in your child class as well as in your TV. Okay, without mentioning anything means all are public only. And then module TB. So transaction TR, initial begin TR equal to new. So I can assign the value for data only. I can't assign for the value for my ID. Okay. Suppose you are exit from your company, your name will be replaced. So another person came, another person joined. That name will be replaced, but ID number is same. Okay. And few companies are maintaining the same IDs, or few companies are whoever left that company, so their ID will be keeping constant, and next person came means that ID will be increased. Okay. So in this way, they will assign the values. Okay. See dollar display, I can write that data equal to percentage 0D and an ID equal to percentage 0D. So I can call this ID directly because I have assigned the value directly, that is the global value. Okay. So that is while declaring the ID or numbers or properties in your class, they are, at that time only you are assigning the value. Those are called as global constants. Okay. Now you want to assign the value for this transaction dot ID equal to, you want to change the value 20. So this is not modified, cannot modify constant variable. Okay, if you want to modify, then you will get the compilation value. Okay, and then instance constant. Instance constant means instead of assigning the value immediately, you are assigning later, but constant property only. Okay, constant property only, but you are assigning the value in your constructor, or through constructor you are assigning, or in your TB also you are assigning that. Okay, constant ID, int ID, then ID value you are assigning through constructor method, ID equal to 101. Okay, two ways you can assign, right? In this way also, function new int I, you can take that. After that, ID equal to I. So this I value will be assigned to ID. Once you assign the value in your module TB, so instead of transaction TR equal to new, then TR equal to 10 you can assign. Then ID value will be 10. In this way also you can assign, right? Next, I told you, constructor with argument. Okay, with argument we can assign the value. If you want to change the value, you can create the multiple objects. Packet P1 and then comma P2, comma P3, comma P4 and so on. So different object, different handles I have created here. And then packet 1 equal to P1 equal to new of 100 and P3 equal to new of 50 and then P4 equal to new of 150. In this way, you can assign the values. Okay. So then call the method. What is your constructed method? So new method. So then I can assign the value through the new method, and then I can display my P1, P2, P3, and P4 values. I can change it. Instance constants. Instant constants. At the time you want to change, you can change. Same way, some protected example, uh, class Ethernet packet, and considering that strings, not only variables, you can also constant strings, you can maintain them. Constant string equal to string protocol. String protocol that is equals to Ethernet. That means your name. Variable is protocol. What is your string name? Ethernet. Okay. Some Ethernet protocol I am utilizing that. That will be assigning in your TP. You can call through the handle of your class member and then you can display it. Okay. Same way, unique transaction ID. Unique transaction ID means instance constants you are using. Every time you can change the value. This this is the previous example. Okay. In this example, you are creating the unique ID only, right? So every time P1, P2, P3, P4, and so on, so different objects, different handles you are creating. All these handles are assigning different values. Okay. Then unique values we are getting that. See, read-only configuration. That means you can out get the output only, right? So read-only configuration means constant int max retry. This int max retry we are assigning the constructor method. This constructor method we are assigning the value. Then we are getting the value, but driver dot max retry equal to 10 you want to assign, that is not possible because max retry is the variable constant. Okay, constant property, we can't assign the value directly. Okay, constant properties we can't access directly. Through constructor method only we can assign the values. Okay, and width also, like you're taking the parameterized classes. In that, you can have the width and depth in your class, right? Same way, I can also assign some int width equal to some 8 you're taking. At that time only you're taking, giving the values, right? That can be called as global constant. But why am not using the constant in front of that? And here I can also use that constant for my width data type. See, constant int data width. For my data width, I'm using this int width. This width will be assigned to data width. Again, you can assign that value to your width data type. Okay, so that means parameterized classes I want to consider here. Okay, same packet source. So source means same method. All are same methods, but different properties and considering and different scenarios I have considered. Okay. So like factory serial numbers, like factory serial numbers means constructor only it is giving the unique numbers we are assigning that 501, 502, 503. So how many employees are there? Those many objects you need to create them. See, can function be constant? No. Method not be constant. Only properties we need to assign the constant method. Okay. So and then we can also use that constant properties. Okay, we can use that constant properties in our class, and that can be assigned to your class handles. Different members we can assign there. Okay, so refers that class handles only. So class handles are not restricting anything. Okay, so here refers handles restriction, not members restrictions. Okay, members can't be restricted. Members can be anything, but you are having different handles means that will be restricted. Why you are taking multiple handles? Okay, you got some confusion. So single handle you can take means single value only I can assign that. Okay. So in UVM, most of the times we are considering multiple objects because all are child classes only, right? So for single parent class, I'm using multiple handles. That multiple handles will be assigned to your child class. So this is the example. You can see this example class transaction constant ID. I'm taking that one property is constant and remaining properties are normal properties, and then construct a new method. Inside that I'm assigning the values to my constant properties. After that I'm calling that I'm assigning the value to the constructor method for my constant properties in my PB. Okay, and then remaining properties calling directly to the class handle. Okay, so read this summary. what is saying that a constant class property, so read only class variables. Okay, only the class variables only read, other members can't read. Okay, you want to assign the variables through constructor only, we can assign that. Okay, those values can be assigned only once. Okay, once you are assigned means it can't be changed. That is global constants, right? And then what is that? Another method. Uh, constant SystemVerilog supports the global constants and instance constants. Global constants, while assigning the property name only, you are giving the value. That is the global constant. Instance means in your that means in your requirement, based on your requirement, you are giving the values. Okay. So after assignment, value cannot be modified. Once you assign this, that can't be modified. If you want to modify, create another object. Okay, just take 2 minutes break. Then I will go for the Typedef classes. చూడండి ఇక్కడ see uh, what I am saying here, Typedef classes, sorry, constant parameters, constant properties, right? Same class, class transaction, constant int transaction ID. That means one property I am considering. This is constant, right? And then address and data I am considering. These two are not constant properties, normal properties. We can call in your test bench directly. And then for this transaction ID, I am using this constructor method. Then ID value is assigned to transaction.id. Suppose you are taking the same name, txn ID only in your transaction, that means constructor method. What is the keyword I need to utilize here? Because I am using this txn ID only. Okay. So how I need to differentiate that one? This keyword we can use, right? This dot transaction ID equal to transaction ID. If you are using the same name in your constructor, then I want to differentiate my constant class properties and then functional arguments. For that I'm using this keyword. Okay, so this dot transaction ID and function void display. In this display I'm displaying the ID and then address data. Okay, transaction ID, address and data. Okay, now normal class method, now module tb. So module tb top and then transaction tr initial begin and tr equal to new of 1001. Okay, so that means 1001 will be assigned to your id and then address and data will be assigned. We can't assign this transaction dot uh, class handle dot transaction id equal to 2000, because if you want to assign this 2000 value here, let's see what type of error you are getting. Okay, understood, right? So we can't assign the value constant ID. See, constant variable is either driven or connected to non-constant variables. That means variable transaction ID declared as a constant cannot be used in this context. Okay. So I told you now. So it is getting the compilation error. So it is showing that constant variables can't be accessed directly in your module. Okay, so now we are getting the output normally, just normal class only, but I'm using the constant. Previously protected I'm used. Here constant parameter, constant values, constant properties. See, I got the value. Clear? You are taking hexadecimal, right? That is the reason it is converted to hexadecimal. Okay, because 1000 and then here 32-bit. See, 32-bit value, how we are assigning the value. So 8 4 is 32. 8-bit values we are taking. Okay. Now, uh, Typedef classes. What is the Typedef classes? Classes will follow that hierarchy, right? Class transaction and then class extended some packet method. So this transaction handle should be represented in your packet class. Otherwise, I don't know, right? Our class transaction and then packet handle you are assigning to your class transaction. Then this class transaction don't know the packet class, right? Suppose I know I have my class and you have some other class. I want to explain for her class. I need to know she need to know my class. Or she want to explain my class and then she need to know her class. This is the cycle dictation, right? So in this way, this typed classes will resolve this one, and then we don't have the cyclic classes. So this typed classes will be assigned different classes because see how it is saying that person A knows person B. Whatever my behavior, you know because you know me. You're seeing me from last 4 months. Okay, somewhat you know something. Okay, I know about you something, right? So I want you again. Person B knows person A. So anyone, suppose someone came near you and asking about me. Yeah, I know he's okay. I'm seeing from last 4 months. Okay, he come this time. I'm going this time, and then you are giving some information, right? Same way here also, two persons are known each other. We are having some satellite dependency. Okay, so that system Verilog faces that same issue in the classes. That will be avoided by using typedef classes. See, without typedef, what is that class employee is there, but we don't know about the manager class. How is assigning the manager class in your employee class? Okay, so that is saying that because class manager is that after the employee class. Okay, after the employee class, before the class you are calling that uh, below class means I don't know, right? Because see something you are taking from me, so I will give you later. Okay, then after that you are not call answer my call means then I don't know. So is that getting or not? So same way. So previously only you need to mention. Otherwise we can't get. So after the class is there or not there, I don't know. Okay. So that is the reason he's saying that compiler reads the top to bottom. Okay. So it is reading from top to bottom only. Okay. So and then it is not reading that bottom classes in the top. Okay. So that's what he's saying that. What is manager? Okay, what is manager? I can't see that class yet. So compilation fails. Okay, so that is the reason. So type def you can mention means anywhere it is there in that class. Okay, type def subclass manager is there. Okay, then compiler knows. Okay, somewhere this class is there. Okay, so that we can trust that. So meaning that trust me. Okay, a class manager is exist. you will see later. This type debt will give you the trust. Hmm. Banks are borrowing the money. Okay, they are giving some bank receipts. DRs they will give that. That means trust. Okay, so anytime they will return the money. Okay, so same way here also, Typedef classes will gives you the trust because they are creating somewhere else, not immediately. After some time, I can create my class. Okay, so that gives you the Typedef classes. Okay, so Typedef class name and an example Typedef class manager. So this does not create the object and memory instance if and only if. So it informs the compiler only. Okay, because typedef can't create any class, right? Any handle, any object, all these things. If you are creating the typedef class, that class you can create somewhere else. At that time, we can create the handles and object, all these things. But initially, it tells the compiler this class is exist. Don't worry. So I can give you the handle for that. Okay. So that's what he's saying that this does not create the object, memory, instance. It informs only the compiler. Think of it as a future class reservation. You are going to the restaurant, calling to the restaurant person, and then before you are going to the restaurant, you are reserving the table. Okay. Same way, the compiler type def class is also working like that. See, without type def, I'm assigning that class A. Okay, class A and B handle. Who is this B? I don't know. I can't see here. In the upside class, I don't have this class B class. Okay, so now this type def class B is there, then class A, B handle you are representing, then class B you are having, then compiler will successfully reach that class B class. Okay. Same way, two classes referencing that each other. That means without type def, master is there, no? So and then master handle we can assign in the slave handle, but slave handle we can't assign that. Okay, because compilation failure. Because previously we need to represent the slave class before the master. Okay, then only the master knows that. Okay, and the upside slave class is there. But with the type def, class slave is there and then master class. So in this master class, I'm using this slave s. Okay. So then the slave class is there somewhere else. And then master class is also there in somewhere else. Okay. Based on that, see, in slave class, I am assigning the master class handle and master class, I am assigning the slave class handle. That means if I am there, you will be there. You will be there, I will be there. If you are not there, I am not there. Okay. So that is the reason. So same thing here. So transaction and generator, same thing. So transaction class is there, generator class is there. Generator class is not there, transaction is not there. Okay. So this circular dependency is there. So then the circular dependency will solve this type of classes. Okay. So creating objects later. See how I are creating the objects later. Class type def class B, class A handle, class B handle is here, and then class B is there. I'm creating the members here. Okay. So later I'm creating. So just give me some. And I will give you later. That's me. Okay. So in this way, I need to ask them. So for that you're asking, what? How can I trust you? What is the assurance? Give you blank check. Okay. So then they are trusting you, right? Same way here also. Then creating the class B and then module TB, class handle A, and then A is creating the object. After that, I'm assigning the object through handle A. See, class B handle, who is there? This B handle in which class it is present? Class A. Okay, class A is present, right? So that is the reason. So class A handle I am creating in my TB through this class A handle, I am calling the class B. Okay, so then I am creating the object for that. Then you are giving the values for that. Okay, so you will get the values. Here, actually, class A don't have any properties, but class B having the property. I can use that. You are not using, right? In your, if you want to use in your, I will give you that. Okay, so this trust-based process only exists in Typedef class. Okay, same thing. See, in your studies time, if you have some guide, okay. So, are you studying today? I will ask you. You are not studying today, right? Can you give me that? Can I borrow your guide? I will study today and then return back you by tomorrow. Okay, same thing. So type dev class node is there. This class node I can represent here. In that I am assigning some data here. Okay, int data node next. Okay, so then module DB I am creating different nodes here. Okay, so then I am creating the objects for different class handles and giving the data. Because multiple handles why you are creating, I'm giving different data. Okay, I want to give unique data or different data. Okay, not only giving the single data, I want to give multiple data. For that reason I'm creating multiple objects here. Okay, so then displaying the values. Why you are getting 10 and 20 and 30 only? So because n1 dot data is not displaying here. So n1 dot next, sorry, n1 dot next data. So that means n1 is the object for that node that will represents that next, and then that next will be given to data. Okay, in this way I'm calling that. Okay, so 10, 20, 30, we are getting that. So in three, why you are getting that only 20 and 30? Because n1 dot next equal to n2. Your object assignment doing that. Okay. How you are assigning the object? N1 is my first node. Okay, my parent class node. I'm assigning that some other class node. What is that other class? So class node. Okay, so node is the class I'm representing here. Okay, for the type def classes I'm using this one. N1 dot next equal to N2. That means N2 data we are getting. N2 dot next equal to N3. So N3 dot value, N3 value we are getting. Okay, so some relation. So tree structure. Tree structure means uh, one person is there. Okay, in that I am representing the different values like 16-bit values there. The left side part LSB part, sorry, right side part LSB part, and left side part is the MSB part. I want to represent that left and right. Okay, so that is the way I am representing the node. Okay, tree node. That tree node is gives you that left part and right part. Based on that, you can assign the values. And parent-child relation, same thing. Class parent and then end class and child. So that means parent handle is in the child, child handle is in the parent. Okay. So after that object graph, like objects we are representing, multiple objects. Okay. So employee ID is there. So employee class is the another class, and then another one is department. Department handle is there in employee. Because both are interrelated, right? Because I am the EC department, then I am the employee of the EC department. Okay, so in this way, this is the complete example. See this summary. Typedef classes is the forward declaration mechanism. So previously you need to mention the class, otherwise we can't access in your next classes. Okay, that tells you that a class with this name exists and will be defined later. Okay, something on my name it is declaring. Okay, so then the object creation it will be done by the later. Okay, so that's what. And the primary purpose is to solve the situation where one's class needs handle to the another class. Before that, you need to define that class name, not fully, right? So just see, if you want to buy something, any property, I need to give some advance, right? So that means assurance. You are not buying, you are not selling to anyone. That is the assurance is providing this type of classes. Okay, clear? We'll go for the example and then winding up. So typedef classes, typedef class driver. This driver class is there somewhere else. Okay. So then um, class transaction. In that transaction, I am assigning one property. Then driver handle I am utilizing in my class transaction. After that, displaying the property here. Address is the property I am displaying through method. And then class driver, in this class driver transaction handle is there. Okay, and then method I am displaying that I am calling this display method in my driver transaction handle dot display. Then we are getting this display method here also. Okay, and then module db transaction dr. Okay, then driver drv. So this is the handle for your driver class handle and then transaction handle. And then I am assigning the object for this driver handle object and then transaction class object. After that, I am giving the values here. Transaction dot address equal to abcd. Okay, this driver handle I am assigning to this driver handle. See how we are assigning this one. This is the driver, right? This is the transaction. So in this driver handle is there. I'm calling this driver handle here. Okay, transaction dot driver handle equal to driver, because this driver is the memory for your driver class. Okay, because I'm depending on that. My driver is depending upon the transaction class. Transaction class is depends upon the driver class. That is the reason I'm giving this handle. Okay, so this is object assignment. Okay, so object assignment. After that, you are calling this method. Where is this method? Send as the method. This is the method. By this method, I am getting the address also. Clear? Just run this. See, address you are getting. One handle. So two handles, one display. You are calling. Okay, fine.